Today, we will talk about definition of related rates, why we use related rates, what to solve, and problem solving in related rates. Definition of related rates. What is related rates? Related rates problems involve two or more variables that change at the same time, possibly at different rates. If we know how the variables are related and how fast one of them is changing, then we can figure out how fast the other one is changing. This usually involves writing an equation relating the two variables and taking the derivative of the equation with respect to time. Implicit differentiation is often used in related rates.
Why we use differentiation? To measure the change in one variable with respect to per unit change in another variable.
For an example, balloon is being filled with air. Both the radius of the balloon and the volume of the balloon are increasing. We use related rates to relate both quantities. Another example, we want to determine the speed or distance covered in miles per hour or kilometer per hour when we ride a bicycle.
So the next part is problem solving. Let's solving the problem together. So the objective of the problem solving is to determine the rate of the top of slide. The second objective is to apply Pythagoras theorem formula in differentiation. Let's read the question together. A child slides down a frictionless 15 feet playground slide. The bottom of the playground slide is initially 12 feet along the way from the climbing ladder. Suppose the child to begin sliding down the slides without any problems. How fast does that child will reach the bottom of the 15 feet long playground slide? And the child is moving at the rate of 6 feet per second. At the right, we can see the picture of the playground slides. The first step is step 1. Draw an appropriate figure and label those given information for better understanding. Info given in the statement is dx over dt is 6 feet per second, which is the speed of the child sliding down the playground slides, and the hypotenuse is 15 feet, which is the measurement of the slides, and the bottom of the playground slide is 12 feet, and now we are trying to find dy over dt. Step number 2 is apply the Pythagoras theorem. In order to find the dy over dt, and the formula of Pythagoras theorem is x squared plus y squared equals to c squared, and after we fill in the formula with our information given, we get x squared plus y squared equals to 15 squared, and then we get dy over dt in bracket x squared plus y squared equals to d over dt in bracket 225, and then we apply this formula to x dx over dt plus 2y dy over dt equals to 0. Step number 3 is we have to find the measurement of y before we take any further action to find dy over dt. So, from the statement given, we already know that the measurement of the hypotenuse is 15 feet and the bottom of the playground slide is 12 feet. And then we apply with the formula of Pythagoras theorem with the information given. We get y equals to 9 feet. The last step, which is step number 4, we already know that x is equals to 12, the x over dt is equals to 6, and y equals to 9. And then we apply with the formula to x dx over dt plus 2y dy over dt equals to 0. And then after we apply the formula with everything we have, we get 2 times 12 times 6 plus 2 times 9 dy over dt equals to 0. Finally, we get dy over dt equals to negative 8 feet per second. So the final answer is negative 8 feet per second.
For conclusion, related rates problems involve finding a rate at which a quantity changes by relating that quantity to other quantities whose rates of change are known. The rate of change is usually with respect to time because science and engineering often relate quantities to each other, and the method of related rates have broad application in this field.